To the next topic, that is using spice. So we know that spice is basically used for analog simulations. Okay, so if you elaborate spice, it is simulation program with integrated circuits emphasis. So this is the full form of the spice. Okay, so analog design engineers are using this language in order to perform analog simulations. Okay, spice is a general purpose analog simulator and contains model of circuits such as resistor, capacitor, inductor, semiconductor devices. So like digital design, we will usually model with Verilog or VHDL. Okay, similarly you can model resistor, capacitor, inductor much more accurately at transistor level. That is what they are talking about spice. Okay, so spice handle complex non-linear circuit as it can perform the following function. Okay, so what all the things that a spice can handle is calculate the DC operating points. So suppose you take an example of inverter. So in that case it will found that operating points, then perform transient analysis. So you can do transient analysis in using the spice, locate poles and zeros of transfer functions. So poles and zeros, we know that we can locate all those things. Perform signal transfer functions, like if you want to perform that transfer function which usually will read in signals system, so we can perform that thing with the spice. Determine the signal frequency responses, so frequency analysis you can do. Determine the signal sensitivity, as it clear. Perform Fourier distortion and noise analysis. So these all things you can model with the help of spice. So why people are going with analog spice simulation in analog design means that is highly accurate. Okay, spice simulations are highly accurate, but the speed and design capacity handled is limited and not suitable for large design. So what they are trying to say is for small design it's okay, you can write much more accurate code with the help of spice, but if the design size is very high or very large, you can say, in that case you can't write a spice code. Okay, because spice code is written for each and every node in the transistors and in the resistor and capacitors. Now they are telling that event based simulators are suitable for digital logic, but they do not provide the required accuracy for analog simulations. So but they have shown the limitations of the digital simulators that which we are using nowadays, that they are not highly accurate. Okay, and you cannot perform analog simulation with that. So they are telling that some of the mixed signal simulation source available in the industry are based on spice interfaced with event based simulator. So spice is one simulator that is analog simulator, and event based simulator is our digital simulator. So we have to integrate both, we have to interface both in order to perform analog and mixed signal simulations. So many solution provider offer their own version of spice tools with features such as front-end design entry, schematic captures, comprehensive device libraries, links to digital simulator, data analysis and graphical user interface. So front-end design entry means they are talking about you can take the design from the front-end side, like there is you can port the netlist. Okay, that they are trying to. Schematic captures means you can draw the transistor level diagram and you can simulate that thing. Comprehensive device libraries, so you can use the libraries. Link to digital simulator, you can there is an option by which you can integrate the digital simulator with analog simulator. Data analysis, graphical user interface, GUI interface also they are providing in order to make the life of designers simple. So this was all about why to use spice and how to use spice. Okay, coming to simulation methodology. Okay, how to perform mixed signal simulation. So step 1 is enter the design. First we have to take the design. So how to take, what all the things are there. Initially the design is described in behavioral level or through schematic entries. So they are trying to say is like if you are writing a behavioral level means they are talking about analog and mixed signal language, like Verilog AMS is there and VHDL AMS is there, and you see Cadence their own proprietary language is there, that is Spectre HDL is there. So you can write a behavioral code in any one of the language. Okay, and after that you can run the simulation. for analog part of the design. So Verilog A and VSDL AMS is used for analog and mixed signal simulations. The behavioral model can be used to speed up the simulation since circuit level simulation is time consuming. So what they are trying to say is like, here you are in behavioral model, you are only describing the functionality. Okay, you are not talking about the implementation details. So that is why these behavioral models are much more faster than circuit level simulations. Circuit level simulations mean you are talking about transistors and that simulations. So they are shown. So this is mixed signal component library, this is interface element libraries. Okay, so design specification. Now design description, so either you will give the description in schematic or you will write in behavioral code. Okay, so if Verilog A is there, write behavioral code. If you do not want to go with Verilog, you want to write spice, then you go with schematics. Okay, select simulation option, whether you want to perform the analog simulation or digital simulation. So you have to perform analog simulation, right? Add interface element. Now you want to interact, right? You want to interact with the digital and analog. Okay, so that interface elements that you will take from the library that will interact. Okay, create simulation test bench. Now we have already created a test bench for simulation purpose. Select analysis. So analysis, like there is an option in GUI format. Like you have to select the option whether you want to go with AC analysis, whether you want to go with DC analysis, transient, whether you want to go with noise analysis, Fourier transforms. All those things you can select here. Then you will get a netlist. After running the Spectre code, you will get a netlist. So that netlist may be either in hierarchical mode or in flat. So two options are there. So either you will get a netlist in hierarchical mode or flat mode. After that you have to run a simulation, okay, and analyze the report. So if analog, basically in analog design means you have to see the graphs. Like if you are running a simulation for an inverter at transistor level, so during that time you will get some graphs, and you will get one report also. So you can find the bugs with the help of reports, and you can analyze the result with the help of graphs. So this is all about mixed signal simulation. Okay, so first step is how to enter the design. Second option is select simulator option. Okay, so in simulator we are having many options, so we have to enable some switches. For that they are telling that select simulator option. The simulator used in the environment provide a number of options and should be set up for required configuration. So that is what I told you, like you have to enable switches based on your application.